We'll simplify this first one by the order of operations, of course. So the order of operations means that we're going to have to start with this set of parentheses first with this 2 minus little 9er right there. 2 minus 9, we're taking away more than we have, you guys, so it's going to be negative 7 right there. And I'm just writing over it because I don't really have the space to do it otherwise. So the next one we got, well, that's all the parentheses. There's no exponents or multiplication even from left to right. I guess I do see that minus negative business right there, so I'm going to change that to a plus right now so I don't have to look at that garbage any longer. Next up then, I would do 8 plus negative 5, which is negative 13. And now right there it's showing plus the 7, so if we combine these two, the negative 13 and 7, that'd be negative 6. And then next up, negative 6 plus negative 3 is going to be the old negative 9er. And then finally, negative 9 plus 24, I can circle, this part right here. That's going to be, looks like it's positive 15 for us. And negative 9 plus 24, positive 15. There we go. And again, we've taken many different numbers right there and then forced them to our will to be just one individual number. We combined them all, okay? Now, one thing you guys should be noticing by this time, because it's not really thought of very often, but could we do this backwards? We could. Yeah. Like, could I take a 15 and split it up? I could. I could split 15 up between negative 9 and 24. And that skill of just choosing what you need or want it to be will be extremely crucial, especially in the next unit. Okay. So, number 2, we're going to continue working with the order of operations. And I always scan it from left to right, so I'm looking at this 5 minus 12 first. And again, we're taking way more than we have, so this ends up being negative 7 right there as well. But there's also this other set of parentheses. The negative 6 in parentheses I'm not worried about because it's just an individual number. Right there, that shows negative 8 times 2. And they did something you should never do, and that's use an x for multiplication. Stinging jerks. So please don't do that in the future. But negative 8 times 2 would be negative 16. Now, we'd have to further evaluate that absolute value because negative 16 is actually 16 away from 0, all right? So I'll go ahead and rewrite this expression as I can have space right there. I got negative 7 times negative 7 right there. That's a 7. Plus 4 times negative 6. And then that looks like it's minus 3, and that'd be multiplied by 16 right there. So at this point, I'm looking for any exponents, but there are none. So we got multiplication though, 2 of them. We got negative 7 times negative 7, which is old 49. This is positive, by the way. And then here on the right, we got 3 times 16, which appears to be 48. 48 right there. Oh, we got I'm sorry, skipped one. 4 times negative 6, which is negative 24. That's why we had 3 multiplications. I missed one. So now we got 49 plus negative 24 right here, and you can put that in parentheses if you'd like. 49 plus negative 24 should be 25. So then we'd have 25 minus that 48 in purple right there. And that appears to be, well, let's look back first. Okay, we're taking away more than we have, which means I know that the answer is negative, okay? But then I can take 48 and then just subtract 25 right there. And then I just know my answer, whatever this is going to be negative. And so some of you guys already had that as 23, negative 23, of course. I should have circled the 15. All right, next up, we'll change this improper fraction to a mixed number, which I don't really recommend very often because when we work in pure mathematics like we're going to be doing, it is better to have an improper fraction. That's correct. So I would recommend keeping it like this when you're actually calculating, but of course they're going to ask us to change this to a mixed number. So here's what we're going to do is we're going to take 43 and divide it by 8. Old-fashioned long division, which we love so much. It won't go into 4, but it will go into 43 5 times. 8 times 5 is 40, so we'll subtract that. Now it gives us a remainder of 3, which means the final mixed number, the whole value is 5. We have 3 remaining out of 8 parts. So it'll be 5 3/8. Next up, for an improper fraction such as this one, I'm sorry, to change this mixed number into an improper fraction, I use what I call cycle method, where we're going to multiply the 5 and 6, and then we'll add that to the numerator. But we keep the denominator the same. It's always going to be the same, unless it could be simplified, I guess. So I do 50 times 6, which is 300. And then add the 1 there to get 301 sixths. Bam. And then finally we'll add these two, but now we haven't gone over a lot of addition of fractions. But here's what I'm going to do is I'll let you guys in on the secret, is you can't actually add or subtract fractions until you get common denominators, which in this case is the 3 and 5. So you don't really need the lowest common denominator. So if anyone has told you that in the past, they've lied to you, which is a very unfortunate thing to do. It's only a partial truth. You can use lowest common denominators, but if you use a common denominator, it wouldn't matter if you used 1500 or 45 even, something like that. As long as they're the same, then you can add or subtract. So I am going to use, I guess it would be considered the lowest common denominator, which is 15. Now why 15? Because 15 is a common multiple between 3 and 5. To change a 3 into 15, now remember, this is all about bending these against their will to our own will. So I've got to change the 3 into 15. I've got to multiply it by 5. Now I don't want to change the value of the whole fraction, so I got to multiply the numerator by the same value. 5 times 2 is 10. So we can look at these two fractions, 2/3 and 10/15, and we should notice that they are the same value. They have the same value, they just look differently, because I wanted that 2/3 to look like a 15th. So 4/5 as well. I'll use a different color. We'll multiply the 5 by 3 to make that 15. So the 4 by 3 as well to make that 12/15. Now we are adding these. And we'll talk about this a little bit more, but we're going to keep the denominator the same in 15ths. And 10 plus 12 is 22. So this ends up being 22/15. And where in the past some teachers have said you need to change that into a mixed number in order for it to be simplified, again, it is lies. You do not need to change that into a mixed number. And let me add to that as well, is in the past when students, because on the test it's like, when we did written tests anyways, before COVID and stuff, it'd be like, you can write the mixed number if you'd like. But then a lot of students, I would see the 22/15 like this, and then in the process of changing it into a mixed number, they make a small mistake, and then I have to mark it off. Okay, so I would just keep it like that. We don't need to do any of that extra work. And it'd be good for you guys to understand that sooner than later, because one thing again, like I've said before, is math people, they're pretty lazy when it comes to writing stuff. So here's our objective. I can add, let me try that again. I can add, subtract, multiply, and divide fractions. That's true. We should be able to do all 4 by the end of this lesson. So we're going to find the area of this blob. Here's what I'm going to do. I'm going to put it in a grid like this. Now when I measured these, actually I didn't measure these. I just made a grid. I don't really give a crap what the units of the grid is, because I can just call these square units, even though they're not squares. I don't give a crap, okay? So what I'm going to do is just kind of look at these and figure out, well, about, I can do some estimation on this, is about how much of a square is taken up by the blob. Well, one thing I see is that if we got these 3 squares right up in here, and they are all filled in as part of the blob. So that would be 3 full parts just right there, okay? I don't see any other full pieces, but what I do see are pieces that I could combine to make full pieces, like this one, and probably this one. Again, it's an approximation, but that would be another 1 right there. And then, maybe, let's see, well, yeah, probably like this piece right here, and then this one. I'd say that also is 1 full piece right there, okay? And then, what else do we got? Let's see, well, maybe not this one. Maybe not that one. Maybe, like, let's take this piece right here, and I'd say if I combine it with this piece right up in here, that'd be another 1 right there, okay? Now we could continue doing this, and we will, but we could also look at these as individual fractional parts. Like this piece right here, you know what, I'll say that that's about a half right there. And then this one, well, if I took this one and this one right here and combined it with this, that looks like it's enough for another 2 pieces right there. And then what do we got left? I got this piece right here, which looks like it's about a 1/4. And then, yeah, this piece as well. I'd say that's about a 1/4 right there. Okay? So we're going to add all these together. Now, if I was doing this just by hand, straight across, I'd say, well, I'm getting to combine all my whole values, which I could use the commutative property to show, but I shouldn't need to. So I'm going to combine 3, 1, 1, 1, and 2, which is 8 full units right there. And then what do I got left? I got a half, and then a 1/4 and a 1/4 right there. Now, without doing the fraction part of this, I'd say, well, a 1/4 and a 1/4 would combine to be a half. And then if I combine it with another half, it'd be 1, which would give us a total of 9 square units on this one. Now, you didn't have to get exactly 9, obviously, because you may have estimated slightly different or even more accurate than I did. And did I estimate very accurately? I'd say no. But it's a blob. And so I feel I can only really estimate that, especially since it's on the board for you guys. And to measure that, I'd have to use like feet or maybe even yards, which I don't think anyone really wants to do. So I'm not going to, okay? So if you got something else, depending on how big your squares were or how small they were, you may have gotten more or less than I did. But again, based on the way that I'm measuring it, I get 9 out of that. All right, take 2 minutes and find the area of this blob as well. I would say that if I were to combine it with, I think this one right here, that if I combine those 2 areas, it'd be about a full square right there. So that's like 2 of them, right? In fact, we'll just keep track of them up there. There's 2. And, let's see. Yeah, that's not so much. Well, what about, I guess, this one and... I'd say if you combine it with this one right here, that'd be another full unit right there. That looks pretty good. And probably like this one with this one right here. There's another unit. And let's see, well, these ones are kind of big. That's okay. Well, I'd say if I combine this one right here with probably like this piece right here, that'd be another full unit. That's 5 right there. And just continuing. Well, yeah, I'd say if I combine this one with this one, that'd be like another full unit right there. Now, the rest of them, we could combine, but then it gets a little bit more complicated than I would like it to be. So, we'll look at these as more fractional type values. So I'm going to start in the top left. I got 6 full units, and that's good. But in the top left, I'm going to say that that's about 3/4 of a unit right there. And then this one right here, I'd say it's about half a unit right there. And this one right here, I'd say that's probably about a 1/3. I don't think I missed any. And then this one, well, what the heck? Looking at this one right here, I don't like that one. It's close to a full one, but that's okay. You know what? We'll just say that it's I don't know, 7/8, I guess. And then this one right here, it's not quite a half. Maybe. Let me think. Maybe 3/5, something like that. Not 3/5, 2/5. I mean, it's not quite a half. You know what I'm saying? So 2/5. That's what I'm going to say. Now you probably got different values, and that's all right as well. Okay. So our answers may be different, especially depending on how big you drew your squares. And I would say the smaller the squares you draw on this, the more accurate you would be. But just for the purposes that we need for this lesson, this will do. All right, so I got the 6 units in red. But I got to take these other parts, right? We got 3/4, 1/2, 1/3, 7/8, and 2/5. All right. Yeah, it's pretty ugly. But in any case, we can still work with it. So looking at this, if we were going to add these together, we got to be careful when it comes to fractions, you guys. Because I can't just take this 3/4, right? We're gonna add all these together. And by the order of operations would say, you know, we got to add these from left to right. But we can't just add them directly like this, right? Like 3/4 and 1/2. Some people would say that's 6/4 right there. I'm sorry, 4/6. 4/6. And you may be wondering how they even came up with an answer like that. Well, they took 3 and added 1 to get 4, and then 4 plus the 2 is 6. Now, please do not do that because we can't treat fractions that way. So a little bit about fractions is the numerator, which is the top number in a fraction, tells us how many of something there is. The denominator tells us the size of those pieces, all right? Now what that means also is, it'd be like saying, if you got 3/4 of a pizza, and I like pizza, you guys. I like pizza with, you know, bacon and sausage and pepperoni. That's a pretty good mix, pretty good. But in any case, you can't take 3/4 of a pizza and add it to half a pizza directly. You got to actually slice it up so that the pieces are all the same size, which is pretty easy. Pretty easy to do when you're cutting it. But mathematically speaking, we got to be able to do it, well, mathematically. So, to make the pieces the same size means that we need the denominator to be the same size. And so we got a 4 and 2 right now. We got to get them to be the same, right? So we got to change these. Now this is where math becomes kind of like a power trip, I'd say. And I'm going to write the 5 over here so I can give myself more space. All right. Well, if we can empower ourselves to force the denominators to be the same, then, well, we can do that with pretty much anything. So here's what I'm going to do is I'm going to scale this up. I got 3/4 and 1/2, right? Well, the 3/4 is fine. And I'm going to keep that denominator as a 4, but the 1/2, no, I don't want that. I need the denominator to be 4, right? So the pieces are the same size. Well, all that means is I doubled the number of pieces to really cut down the sizes in half. But if I do that, I've got to double the number of pieces, okay? So that would end up being 2 pieces out of 4. Now, if we analyze these two fractions, 1/2 and 2/4, I have not changed the value, which is crucial when we start changing values, okay? I haven't changed its actual value. If you got 1/2 of a pizza or 2/4 of a pizza, you'd be like, man, I want the other half. But that's all we got, okay? But in any case, it is the same value between the 2/4 and the 1/2, okay? So now that I've done that, I can combine these to create a new fraction. I would have 3 pieces and 2 pieces, which is 5 pieces, and the size is in fourths still. Okay, so we added the 2 numerators, and well, we kept the denominator right there, all right? Well, the rest of this shows we still got a 1/3 and then a 7/8. It's kind of a long journey here, but we'll make it through. And whatever we get out of it, we'll just add to the 5 right there, and that'll be good. So next up, I'm going to add that to, well, the 1/3. Now, the denominators are not the same, which we need when we add and subtract fractions. So I'm going to force them to be the same. And so I may think of some multiples of 4 and 3, such as 12. That should work. But how do I make a 4/12? Multiplied by 3. So again, to maintain the equality of the fraction, I got to multiply the numerator by 3 as well. So there we go, 15/12. And then the 3, yeah, we'll have to multiply that by 4. So 1 by 4 as well, making that 4/12. So now I can add these to give me some number of 12ths. And 15 plus 4, bam, 19. Now if you guys were like, dude, I need to make that a mixed number, you don't. And in fact, it's better to keep these as improper fractions like this. because they're easier to work with, which we're hopefully finding out. So we still got the 7/8 piece and the 2/5 piece. That's the one that's going to really be slightly painful. And yeah, we're adding these together. Okay, so again, moving from left to right, I got the 12ths and the 8ths, but I need those denominators to be the same. So again, you may think about, well, what's a common multiple between 12 and 8? And if you thought to yourself, we're going to use 24, yeah, you'd be right. That is a common multiple between 12 and 8. So yeah, we multiply 12 by 2, 19 by 2, and that'd be 38 twelfths right there. So 8 would have to multiply by 3, and so 7 by 3, 21 24ths. Yes, we are going to add these to get 59 24ths. And again, I know this is looking pretty ugly, and that's not supposed to be 5 right there. Sorry, I miscopied that. It's a 2/5 right there. All right. Now I got two very different denominators on. All right, so 59 24ths and 2/5. Now, I'm not very familiar with my 24 times tables to find a common multiple with 5. So all I'm going to do is multiply it by 5. And here's why, is if I multiply the green fraction by the purple denominator, then I can take the purple fraction and multiply it by the green denominator, which is 24, right? And this guarantees that we will have common denominators, automatic, and that denominator will be 120. There we go. And then 5 times 59, 250, 295. And then 48, right there. All right, so in 120ths, this will give me the answer for this one. In 120ths, that's okay. So 295 plus 48, it's a 3, and then a 14, and 343. The last thing we can't forget on this one is that we had the full 5 units from before, right? So I got to add this to 5.
Isn't it 6?
Was it 6? All right. Yeah, so it was 6. That's correct. There we go. All right, so that should have been a 6 right there. So we're going to add it to 6. Now, how do we add fractions to whole numbers? Well, whole numbers are actually fractions. Just make that 6 over 1 right there. And the great news is to scale a denominator of 1 is so easy, so easy. All we need to do is multiply it by whatever the other denominator is, which in this case is 120. So I have to multiply the 6 also by 120. All right. All right, so 120 times 6, 6, 7, 20, right there. Add a 120, and then yeah, we're going to add it to the 343 1/20ths addition. 1/20ths, there we go. So let's add these together, and we're going to get our answer in 1/20ths, and we'll see if we can be simplified, but I don't think we'll. So that'd be 1,063. That's a 0. All right, so the last thing I would do for this fraction is just see if it could be simplified. 1,063, it's not divisible by 3 or 2 or 5. 7, 36, 5. Nope, it's not divisible by 7. Well, 120 is not divisible by 7 anyway, so it's not divisible by 3, 2, or 10 either, so we're good. Now, if some of you guys were like, dude, we got to change this thing into a mixed number, stop it. Because just like I've said before, is working with these improper fractions, mathematically speaking, though we don't have a lot of experience with it yet, you'll see that it's a lot easier, okay? So, we're going to keep this as the answer. I'll label it in units. And the units were already squared, so, well, rectangular. So we'll say units. Whatever those units were, I don't really care. One of the main things we want you guys to see on this is that we were just adding and subtracting, well, adding the fractions. And whenever you add fractions, you need common denominator. Alright, so this says draw a picture or diagram to show how to solve each of the following problems, then write the number sentence associated with the problem. So we use the diagram. Now, do you have to use diagrams in the test? No, you don't. So if you're like, I understand how to do it without the diagrams, you're good. Okay, in fact, if you're like, I don't even want to do the diagrams, you're good still. But in any case, number one, you have 3/4 of a pizza left. If you give 1/3 of the leftover pizza to your brother, how much of a whole pizza will your brother get? Take 1 minute and see if you can solve this with your neighbor. 1 minute, go! So I've already drawn the picture for you guys, at least to start with. But we got to figure out the rest of this thing, right? So if I was using the diagram, and I do like the diagram, and you know, there's not a lot of rectangular pizzas like this, but I like to eat them anyways, especially when they got pepperoni, sausage, and bacon. But that's a whole different story. So you have 3/4 of the pizza, so we can see 3 pieces shaded red out of the 4. So the one that's white there would be eaten already. And yes, I ate it, and I'll eat the other 3/4. But in any case, you're going to give 1/3 of the leftover pizza left to your brother. Now 1/3, right? As of right now, we got it already split into 3 parts, like this right up here. So one of those pieces is this piece. Now of the whole pizza, that would have been one of the 4 pieces, just like all the other pieces were one out of the 4 pieces as well. Okay, because the 1/4 that I'm showing here in purple is of the whole pizza. So that's how much your brother's going to get, 1/4 of the pizza. Now it's not 1/4 of a piece, which would be the wrong label for this one. It's 1/4 of a pizza. Now that is how this would be shown with a diagram, and it's very pretty. What they also want is to show this using a number sentence, okay? So an actual expression. So on this one, I'm going to take that 3/4 right here. That's how much of the pizza is left. So we're going to show that right there. And we're going to give 1/3 of that to the brother. Now, this would show it's 1/3 of 3/4, which means we're going to multiply it. It's 1/3 of a piece, or I'm sorry, 1/3 of a pizza. So 3/4 times 1/3, and yeah, you guys see that you can cross simplify the 3's there. 3 divided by 3 is 1. 3 divided by 3 is 1. Now this is fraction multiplication, where we multiply the 2 numerators together and the 2 denominators for a new set of numerator and denominators. 1 times 1 is 1. 4 times 1 is 4. But again, this would be of the pizza that's left over. So your brother gets 1/4 of that pizza. So let's talk about that, because we do need to know this. So if I were to read this just as straight multiplication, right? Excuse me. Is I'd say, well, let me show a different example, which will hopefully help us relate this. Okay. If I said I have, well, let me use different numbers. This would show 5 groups of 2, right? Now that's multiplication. 5 groups of 2. Which would show as, what would that be? 2 plus 2, 5 times over, as repeated addition. I don't know that it really applies in this case, but what I really want to focus on is that multiplication will indicate how many groups of something we have. So this would read 5 groups of 2, which is still multiplication, right? I know I've said the same thing over and over because I want to emphasize what multiplication is. So over here in green, let's go ahead and write this out, okay? This would be 3/4 groups of 1/3. In fact, what I would like to do is actually rewrite this, which is going to make it maybe easier for us to understand. It'd be 1/3 groups of 3/4 is really how this would read from the beginning, okay? But because it's multiplication, it doesn't really matter the order. That's the commutative property of multiplication right there. So I'll write this out. Well, a third group of 3/4, that's when I would be looking to use the model on this, where I see I have the red, which is 3 parts of the 4, 3/4, but it's a third of that group. So a third of that group is that purple piece that I've already shaded right there, right here. So that's where the multiplication makes this even what we would consider a smaller value. A third group, a smaller group of something is going to always give you something smaller. So a third of 3/4 is that 1/4 piece. Now, well, why does that work with multiplication? Well, it's because it's a third group of 3/4, which is what makes it multiplication. Now, I use cross simplification for that, and I kind of expect that you guys have seen that before. But let me show this a different way. Now, you're always going to multiply the numerators like this and the denominators, no matter what. Whether you simplify now or later, which we're going to have to in a second. So you'd say, well, 1 times 3 is 3, and then 3 times 4 is 12. But once you ever see a fraction like this in the end, always ask yourself, can this be simplified? And if it can, then you should. If it can't, then don't worry about it. But this one it could. I'd say, well, 3 and 12 are both divisible by 3, which would then make that 1/4. Okay, so again, it shows the same answer, just in a different method. Yeah, it does come out as a partial group of something, which again, in this case, ends up being smaller. But yeah, that's if we can understand what multiplication really is and what it represents, especially in terms of the wording, not necessarily the repeated addition. I don't know that it's important for us to know, and I'd have to think about that for a long time anyways. Okay. So when you're multiplying fractions, and this is abstract, okay, so what that means is all the letters would represent numbers. Well, they could be variables, but it still doesn't matter. Okay, so we'd say A over B times C over D, right? Well, again, with fractions, all you're doing is multiplying the two numerators to get a new numerator, so that'd be A times C. And then you also multiply the two denominators, B and D in this case, and so you multiply those out. Now again, if you could simplify any of that, you would. But this is essentially the simple rule for multiplying fractions. Just multiply your numerators and denominators, okay, to create new numerators and denominators respectively. All right, draw a picture or diagram to show how to solve each of the following problems, then write the number sentences associated with the problem. Emma bought 5 1/4 yards of fabric. She used 2 2/3 yards to sew a dress. How much fabric is left? Oh, that's very good. Go and see if you can solve this one. 1 minute, go. So I kind of fixed the diagram to show. Now all of that would have been existing for Emma on this one. That would be 5 1/4 right there. All right, we got this one right here and this one. That's 2, 3, 4, 5, and then this is a fourth. You can see it's been split up into 4 parts right there. Okay, so that is 5 1/4 yards of fabric, but she's going to use up 2 of these. All right, so I'll use green to show the stuff that she's used. So she's going to use this full yard right here, and she's going to use this full yard right up in here. But then she's going to use another 2/3 of the yard. Now remember, if we look at this one and we split it up, I guess horizontally, this would be a third right there, and that's a third. So that would be 2 of the third parts. Now how many pieces is that showing right now? Because it's in twelfths. Now that'd be 8 of the pieces, right? So I need to shade in 8 of these. There's 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it was kind of showing the answer from the beginning. But that doesn't matter because that's how it's going to work. And what are we left with? We'll show this both ways. We got the mixed number as 2. And then how many red pieces? We got 4, 5, 6, 7 out of the 12 parts. And again, don't forget to label this in yards, okay? So in red there, that would be what was left over for Emma in this case after she sewed the dress. Now that was just using the modeling, but now we got to show this using actual math expression on this, okay? So what we're going to do is we're going to take her 5 1/4 that she started with, and she's going to use up, it was 2 2/3 on that. But since she's using it, we got to subtract it, you guys. All right, now, again, using just pure mathematics on this, you need to change both of these into improper fractions first. So I would use cycle method on this one. So that's 5 times 4 first, which is 20, and then add that numerator 1 to make this 21/4. And then the 2 2/3, again, 2 times 3 plus the 2. So 2 times 3 is 6, plus the 2 numerator. That's going to give us 8/3 right there. Now we're adding these. But like it shows in the diagram above, is, yeah, we got 21/4 and 8/3, but and this is something you guys need to understand about fractions, is the numerator tells us how much of something we have. The denominator is going to tell us the size of the pieces. So you can't just take the size as fourths and thirds and say, I'm going to combine them to make sevenths. That's not how it works. We've got to divide whatever it is, in this case, yards of fabric, into the same size pieces. All right? So what I'm going to have to do, is change these then into, just like it shows above, in twelfths. So I'm going to manipulate both of these fractions into twelfths. Now how do I do that? Either it must use multiplication or division. We're going to scale these up. To make a 4 or 12, I'd have to multiply it by 3. Now, in order to maintain equality, I've got to multiply the numerator by 3 as well. Over here, for the 8/3, we'd have to multiply the 3 by 4. So the 8 by 4 as well. Again, that's going to maintain equality. It's going to look different, but it will have the same exact value. So that's then 63 twelfths. And then 32 twelfths. Which, when I combine, it's going to give me some number of twelfths. I just got to figure out how many. So yeah, I'm just looking at taking the 63 plus 32, 95. 95 twelfths. That seems off to me. Oh, I needed to subtract, didn't I?
Yeah.
I was wondering, that seemed a little big.
That's what I was raising my hand about.
Thank you. Yeah, sorry. I was getting to it. But yeah, let's get rid of that garbage because it is. Now this will be more correct. Okay, 63 minus 32. That's much better. That's going to be 31 twelfths. And again, that's in yards that she has left over. Well, if you were to make the calculation on this one, you'd see that the two answers actually are the same. On that one, 2 and 7/12 yards is the same as 31/12 yards. Like I said, since I already have this as an improper fraction or a mixed number, it doesn't really matter which one you choose. The homework will say it wants just the improper fraction though. Okay, so keep that in mind. So the rule when you guys are adding and subtracting fractions, all right, is that you first have to force the denominators to be the same. So again, this is abstract. This would be represented by numbers. But once you get the denominators the same like this, and you may have to force them to be the same, you guys, but then you're just going to take the two numerators, add them together, and then keep the denominator the same. And of course, after you were to finish that, you would be looking to simplify if you could. Now that's addition, but what about subtraction? Yeah, it actually works the same way. All right, this is going to be a minus c over that same denominator. So again, this would be represented by numbers instead of letters. But that's what we've been doing, and most people don't really show this step right here, these two. Now, see, it's not required that you do, but if it helps you to keep that organized, then do it. All right, you guys, for this problem, we got Jared ate 11/15 of a chocolate bar, and Connor ate 4/5 of another chocolate bar. What fraction of one chocolate bar did they eat? So I'm going to use the diagram here above. And what I'd like to do first is just to split this up into equal parts, right? So I'm going to take each of these parts that this bottom chocolate bar was in and then make them the same size pieces that the one in top is, okay? So if we do that, then we can see that the top one does show what Jared ate, right, which was 11/15 of that bar. Now, Connor's bar is the same size, it's just that he ate 4/5. Now, instead of showing it as 4/5, we change the size of the pieces so that there's 15 of them. So it's no longer 4 out of the 15 parts. Yeah, we should probably count that, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that'd be 12 of 15 parts. Now, we want to know what fraction of one chocolate bar they ate, so we're going to combine those two. And when we do, we could just count these out, right? You got 12 and 11, which would be 23 pieces out of 15. Now, just in case you were wondering, that's one full bar, right? Because we could take these 3 pieces and then move it here. And then how many pieces would we have left over? It'd be these 8 pieces out of 15 parts. So either one would work. I do prefer the improper fraction on this, okay? It's just easier to work with, mathematically speaking. So what fraction of one chocolate bar did they eat? They ate 23rd 15ths of one chocolate bar, or you could say that they ate one full chocolate bar and then 8/15ths of another. Now the number sentence part of this is pretty much exactly like we saw in the beginning. You start with Jared's chocolate bar, 11/15ths, and then Connor's chocolate bar, and he ate 4/5ths, and then you would add those. And the important thing that we need to remember on this is the two denominators, as of right now, are not the same. They got 15 and 5. So what did we do? We had to scale up the 4/5ths into being some number of 15ths, right? And we did that essentially by multiplying excuse me, each of the 5 parts by 3, which is what we did in each of these 5 parts in the diagram, right? So we changed those to 15ths, but how many pieces did that make now? It was 12 pieces. So that ended up being the same as 11/15ths plus the 12/15ths, and that's when we get either one of these two answers right there. So Jenny's mom says she has an hour before it's bedtime. Jenny spends 3/5 of the hour texting a friend and 3/8 of the remaining time brushing her teeth and putting on her pajamas. She spends the rest of the time reading her book. How long did Jenny read? All right, guys, take a minute, see if you can solve this one. 1 minute, go! So to start this off in red, because I did draw the diagram up here at the top, is in red, this is, I guess it was the 3/5 part of it, okay? So this whole bar up here, this one, would be the full hour, okay? And that 3/5 in red there, that's, looks like it was texting a friend. Yeah, so that's texting, okay. I don't know if that's a lot of time texting, but maybe you guys do. So that's texting right there. And then it says 3/8 of the remaining time. So the remaining time there in white, I just kind of dropped that box there into the green and purple. And you see how it's split up into 8 parts. The 3 parts in green would have been the remaining time that was brushing teeth and pajamas. So that's like PJs and teeth, okay. Now I did say that the rest of the time she spent reading her book, which is in purple, so this is the book portion. And that's the value we want to figure out. How long did Jenny read? Well, I didn't really say the units, so if you guys wanted to keep it in hours, that's probably what I'm going to do. Though I think this would work. Maybe not. We'll see. These are all split up into equal parts, by the way. Remember, this kind of corresponds with this. So it means that if we were to change the hour into similar units, which is really what we should do, then each of the boxes then were split up into 1, 2, 3, 4 parts, right? So that means that these ones also would be split up into 4 parts, like this. I know it's not pretty, but it still works. So we'd say, well, how many parts are there now? Well, we had 5 boxes in the beginning. Each was split into 4 parts. That's going to make this in 20ths. And then the purple portion is 5 of the 20 parts. Now 5/20ths, again, you should always look at the final fraction like this and just see if it could be simplified. And 5 and 20 are both divisible by the same value, which is, well, 5. So I'm going to scale this down so that it's fully simplified. And 5 divided by 5 is 1. 20 divided by 5 is 4. So, the last thing you should do on this is to label your answer. Mine's in an hour, 1/4 of an hour. And yeah, if you put 15 minutes, it's the same value, but we're really dealing with fractions on this, so I'm going to keep it. So I'll write some rules for adding and subtracting fractions. You just always need common denominators. Always need common denominators. It is more common to use improper fractions than mixed numbers. That's true as well.